Hello and welcome to this lecture on Introduction of Java. In this lecture, I'm going to introduce you to the programming language Java. So let us start with some of the attributes that are defined inside the white paper of the Java when it was launched. The first thing is Java is the platform independent language. What do you mean by platform independent language? Platform independent means a program can run on any of the platforms. Let us say there is Windows machines, there is a Linux machines, as well as there are Macintosh machines. There is no need of different source code for different environments. The same code can run on different machines. So this is platform independency. How does this happen? This happens to a feature called as Java bytecode. Whenever there is a Java file which has a Java source code in that, the JVM would generate bytecode for each of this file. Bytecode is an optimized instruction set designed to be executed by JVM. So this bytecode is generated by Java compiler. If Java source code is converted to bytecode, then JVM needs to be written for each of the platform. Say, I have a Windows machine and you have a Macintosh machine. So implementation of JVM would be different for these two machines, whereas source code would remain same. The earlier notion of having different compiler for different machines is changed into a different JVM for different architectures. So bytecode is the one that is acting as an intermediary now. JVM acts as interpreter for bytecode to underlying system. When Java compiler converts the source code into bytecode, the JVM acts as an interpreter, like how each statement of bytecode has to be executed as a system command. This is handled by JVM. So JVM has a major task to be done, and it has to take care of things in optimal way. Converting to bytecode and executing it by JVM may seem like slow, but in real time, it is very fast. Let us say in case of C++, everything is converted to the object code. The programs run very fast. Programs may not be as faster as that of C++ in Java, but in real time, you won't see a difference. So this is only because of the bytecode and JVM implementation. For improving the performance further, there is something called as a JIT compiler, which is introduced. This JIT compiler converts the bytecode into executable code at real time. It does not convert whole of the source code at one instance. It just takes certain bits and tries to convert it so that the machine runs in optimal way. Java is also attributed to be a simple programming language. There are reasons for that. Because Java is inherited or inspired from languages like C and C++, and most of the people earlier were developers of C and C++. Learning curve for them was simple. So people were learning it very fast and trying to write the softwares with Java programming language. And for anyone who has prior knowledge of programming knowledge, it was easier for them to understand and write software with Java. That's why it is called a simple programming language. Java is also known as an object-oriented programming language. What do you mean by object-oriented programming language? Everything in programming language is treated like an object. So if you want to create a variable, then it has to be dependent on certain class. Like if there is a person, then you need to map it to a real world object. This is object orientation in a programming language. You just treat everything in a programming language like the world you see around. Java has an inbuilt object model, which is easy to extend. Each of the object in Java is inherited from a base object called as object. O capital BJET, object. There are two kinds of objects in Java. One is primitive type and others are composite types. The primitive types are like floating types, integers, and these are treated as non-objects. These are kept out of the object model for a reason of performance. If you keep them out of object model, the machine would perform rather faster. That is the reason these are kept as non-primitive objects, primitive objects. It also strikes right balance between object-oriented programming and performance using the primitive types. Just now, as I explained, the primitive types help in fast execution of the programs. Java is also attributed to be a robust programming language. Why? That is because Java has to run reliably on different kind of machines. JVM is a different implementation for different architectures. Same source code would remain similar on all the architectures. It is a job of Java to run the program in a similar way on all the platforms. So it does it. So that is called as robust. And also, the failures in computer programming language are mainly because of two reasons. One is because of the runtime exceptions and other is because of the memory management. If you have prior experience with C++ programming language, you would be knowing how hard it is to manage the memory. Every time you need to create the objects, you need to delete the objects, even the arrays, you need to create and delete. Whenever there is a pointer involved, the life would become hard. So to solve that problem, Java came up with something called as garbage collector. You need not manage the memory yourself. You just need to create the objects, use it for your convenience, and later let the garbage collector delete it. So it is none of your concern. And also, you need not worry about the amount of memory that is left in the computer running heap. Also, there is one more thing called as Java exceptions. Instead of failing late at later stage of while computer program is running, the exceptions are introduced in the Java programming language. With exceptions, you can assume something bad is going to happen and abort the program safely. Instead of saying some segment errors and memory leaks, it can safely exit out of the program saying that there is some issue with the memory. It is better than exiting the software abruptly. And also, Java program supports the strict typing. Strict typing helps us to identify the problems at the compile time itself and resolve them at the same time, so that there are not many issues at the compile time, which would lead to complex runtime issues. Java also supports multithreading. Multithreading means doing the same task in different threads in parallel way. They share the same memory through a process. So this feature is inbuilt into the programming language. Java also supports distributed environments. Like there is something called as a remote method invocation. You can call a different function located in a different machine altogether from one API. This helps in having a file-like access in computer programs. Java programs mostly are dynamic. This is because most of the Java programs contain large amount of runtime information. This runtime information contains metadata like the type of the class that is going to be executed and amount of memory that it is going to take. Such kind of information will be stored in the metadata. Such metadata helps us to replace some of the byte code at the runtime. This would help us in turn to write better software and build up new frameworks like Spring Boot, in case you are interested.